4.1 RSG. The ready is relatively simple. I don't want to spend a whole lot of time on the ready here for you. And it's review. So let's just brief summary of what you're supposed to be doing here. You are getting a refresher of your first look at rational expressions. Rational expressions are fractions that have polynomials in the numerator and the denominator. And constants are a polynomial. So in one, I have a constant of 18 divided by a constant of 24. So I have a rational expression that I do need to simplify. The process that is involved in simplifying these rational expressions is the same process that we will use later on in this module as we are looking at rational expressions that do have the polynomials of degrees 1, 2, 3, 4, 5 to help us simplify, to solve, to graph, analyze as we progress through this course. So you will need to draw on some of your basic skills with fractions. So let's get started. I see 18 over 24. Well, 18 is 6 times 3, and 24 is 6 times 4. Yes, I could just divide by 6, and that's the way you've been taught how to do these. Find what you can divide by, and then divide by that both the numerator and the denominator. However, for what we are going to be doing as we progress through this course and the module, we need to understand that when I divide by 6, I'm canceling a 6 from the numerator and a 6 from the denominator. I am canceling what they share. So in writing it this way, you get that visual that, oh, they share a 6, so I can cancel, and I'm left with 3 over 4. Can do the same thing in number 2. So this is the last one I'm going to show you. So in number 2, I can rewrite 18 as 9 times 2 and 45 as 9 times 5. So number 1, I knew I needed to use 6 because I have an awareness that 6 goes into both 18 and 24. And then in 2, I have that awareness that 9 goes into 18 and to 45. So they share the 9, and I am left with 2 over 5. So simplify however you want to simplify, but just be familiar with or understand that you are canceling what they share. That is important for as we progress through this module. So the set, I'm not going to redo number 10. We did number 10 in class. So I'm going to kind of leave that one as is, and I'm going to do one other one with you. I'm going to do number 11. So I'm going to make my table. I do want to use some positives, and I do want to use some negatives. So I'm going to pick, just like we did in 10, -2, -1, 0, 1, and 2. And as I'm plugging in, this is 1 over, let me do the work off to the side here. 1 over -2 plus 2. Well, that becomes 1 over 0. And we need to remember we cannot divide by 0. There is nothing I can multiply 0 by that will give me 1. So this is undefined, which means that will be a vertical asymptote. And don't forget we call those vats. So my vertical asymptote will be -2. When I plug in -1, that's 1 over 1, which is 1. When I plug in 0, please make sure you do show the work and try not to get stuck on the mental math part, please. That's 1/3. When I plug in 1, if I plug in 1 plus 2, sorry, I just completely skipped the 0 and I said 0. Let me start with the 0. That's 1/2. The 1 was 1/3. Just skip that. And then 2 plus 2 is 4, so 1/4. Well, let me plot these points and see what I have here. So I have my asymptote is at -2, so I'm going to draw that in with a dashed line so I know that that's invisible. It's going to help me with my graph. -1 is 1, 0 is 1/2, and then I see that these just keep getting smaller and smaller. And it looks like it's going to approach the x-axis but not touch it. So I'm going to have another asymptote there. But I only have points in one spot. And I know that this graph, because of the asymptotes and my knowledge of rational functions, that my graph is going to have something that looks like that. But I'm missing stuff over here. So I'm going to plug in -3 and -4 as well into my table. So when I plug in -3, 1 over -3 plus 2 is 1 over -1, so -1. And then when I plug in -4, 1 over -4 plus 2 is 1 over -2. So -3 was -1. It's going to use green. -1. And -4 was -1/2. So now I can see the rest of my rational function. Now it's time to list the features. The features I would like to see you listing are identifying any intercepts, x and y. And I do have an intercept here. I have a y-intercept, and I can actually get that from my table. Here's my y-intercept. So my y-intercept is 0, 1/2, and my x is none, because I have asymptotes that are going to keep me from crossing that horizontal axis. I do have a vertical asymptote at x equals -2, and I have a horizontal asymptote at y equals 0. Please make sure you do write these as equations. And then, let's see, I would like you guys to describe the domain and the range. Now we need to remember your domain is attached to your vertical asymptotes. So normally your domain would be -infinity to infinity. But because we have a vertical asymptote, I need to exclude that value. So I'm going to say my domain is all x values such that x cannot equal -2. We need to again remember that comes from your vertical asymptote. And then your range is the y values. And again, we always assume it's -infinity to infinity, but then we need to remember to look back at what are the values that I'm going to exclude. And my range is going to come from my horizontal asymptote, where it is crossing the y-axis. And it's crossing the y-axis at 0. So y cannot equal 0. So I'm going to make a note. This comes from my VAT, the domain, and the range comes from my horizontal asymptote. That's definitely going to help me in the long run. And then lastly, the end behavior. This end behavior, there's 4 of them. So let me use a different color so I'm not using one I've already used. Let's see. Do turquoise. So, no, that doesn't show up too well. Plum. Here, x is going to -infinity. So f of x is going to, so the y, as that arrow goes up, it's not going to infinity. It's only going to go to the 0. And then this one, as x is going to, now we have to look at that vertical asymptote. Your vertical asymptote's at -2, so x is approaching -2, and f of x is going to approach -infinity because it goes down. This next arrow, x is going to the right, so infinity, and f of x is going to the asymptote, so 0. And this next one, as x is going to the asymptote, -2, f of x is going up to infinity. So those are the features I would like to see you listing on the next two graphs. And we will continue to go over these graphs throughout this module. All right, so the last thing that we are going to discuss, and the work that you see here is for number 15. I'm not going to go over 14, 16, or 18. You should be able to factor and solve those. Those are your typical polynomials. Factor them, make sure that these are set equal to 0, and then solve for x. But also recognize 14 and 15 are the same, but in 15 you have an inequality. In 15, you use your solutions from 14, and I made my number line, and then I tested points to see where it was true. I ended up saying, okay, that's where the shading is going to take place. So I wrote my solutions in both interval and set notation. You can choose. Interval is probably the easiest. To give you guys a little more clarification, I'm going to do 17 with you, so you guys can see that one worked out. So in 17, the first thing I need to do is make sure my inequality is set to 0, and it is. So now I recognize that there is an x in each term. So I'm going to factor out an x. So I have x squared plus 5x plus 6. And I could factor the inside. X plus 3, x plus 2. So now I'm going to solve for x. I'm going to use my polynomial skills and know that I would set each of my factors equal to 0. And then I would solve for x and I would get 0, -3, and -2. Now I'm going to use a sign line, a number line. So I'm going to just draw the x-axis here. This is my x-axis. I'm not going to draw the y-axis. And I'm going to put my 3 x-intercepts on this x-axis. So -3 would be here. Maybe here's -2. And then 0. So you just need to make sure they're in the right order. Spacing does not matter. And let's see, my inequality is equal to, so this is going to mean I need a closed circle for all 3. Closed, closed, closed. All right, now I have to test. I have just broken my number line up into 4 sections. A left, 2 sections in the middle, and a right. So I need to test points that are in each of those sections, so I know where the shading is supposed to be. I'm going to test -4, -2.5, -1, and 1. I need to sneeze. Excuse me, sorry. I still feel like I need to sneeze. I'm going to plug these back into the original inequality. So I have to do this 4 times. So I have, and then I've left my calculator at school today, so you're going to have to bear with me using my phone. So here's the first one. So you're going to set that one up, and you're going to check to see if it's greater than or equal to 0. Then you're going to set up the -2.5. Then you're going to set up the -1. And then you're going to set up 1. And we're testing all of these to see that they are greater than or equal to 0. So I'm going to start with the 1s. So this is 1. 5 times 1. And then I have negative 6. 1 plus 5 minus 6. That is 0. Is that greater than or equal to 0? Yes. Now I'm going to work backwards. Negative 1 cubed is negative 1. Negative 1 squared is positive 1. And then I get negative 6. Oh shoot, I see my mistake back here in this one. Man. Hold on, you guys. Sorry. Okay. Well, let's try this again. Take 2. Positive 1, not negative 1. 1 plus 5 plus 6, which is 6 plus 6, which is 12, which is still greater than or equal to 0. But at least my math is right now. Negative 1 plus 5 times positive 1 minus 6. Negative 1 plus 5 minus 6. This is positive 4. 4 minus 6 gives me negative 2. Is that greater than or equal to 0? Nope. In a minute, I'm going to show you what to do with those. Oh my gosh, I'm messing up left and right here. Okay. So now I'm going to get out my calculator. Give me a moment. Bring this sucker up. Okay, let's see. So I have negative 2.5 squared. Cubed is 15.625. 2.5 squared times 5 is 31.25. And negative 2.5 times 6 is 15. So when I add all of that up together, I have my negative 15.625. So 15 plus 31.25 minus 15. Well, I know that that is for sure, without doing any more work. I don't need to add all that up. I know that that is going to be greater than or equal to 0. So I don't need to finish. Once you know that it's yes, please don't finish. I just am checking if it's greater than or equal to 0. Now I move over here. 4 cubed is going to give me negative 64. 16 times 5 is going to give me positive 80. Minus 24. This is not going to be greater than or equal to 0. This is going to end up giving me like negative 8. So, no. So I'm going to take my yeses, and the areas where they were yeses, I'm going to highlight. So negative 2.5 worked. And 1 worked. So now I need to write my answers. So here's my solution. In interval notation, negative 3 to negative 2. I'm using brackets because I have closed circles, therefore they are included. Union 0 to infinity. You could also write set notation. It's more work. Negative 3 is less than or equal to x is less than or equal to negative 2. And x is greater than or equal to 0. You take your pick, however you want to write your solutions. Now, I know that this is a lot of work, and the work is the guess and check part. You pick a number and you check it. Do that on scratch paper. It's just don't make mistakes. Take your time with that. Don't rush. We did one in class. You have this one. You now only have one more to do. So take your time with it. Do the best you can. We will need to know how to do this as we move into graphing more complex rational functions. If you have questions, come and see me. Or when we have our homework question day, please make sure you ask.